Okay, so let's get started with the presentation. And today I want to talk about security. And when we talk about security, when you go to usual presentations about those, I noticed that they tend to focus on one particular aspect. And the aspect is mainly infrastructure, backend servers, API security, and so on. And this is what we usually talk about. And if you think about the classical model of deploying software, we think about it as building a package and shipping it to one of those servers that we try to keep secure. Secure. And we are really good at showing the boundaries of where our data centers are. We have firewalls, web application firewalls, and other tools and measurements to actually keep this part super secure. Now, there's a shift in how we build applications, especially front-end application nowadays. So this model works really great for application like from 90s, where all the visual part of the application was actually rendered on backend server. So all the concepts that we have for security that we talk on conferences are usually okay for this setup. But nowadays, when we are shifting towards single-page applications, we are actually packing the code and sending it out to the user. So what happened in this landscape is that we moved a lot of the stuff to the users. This means that we have a new part of environment that's out there, the environment we don't control. So our security measurements that we have in-house in our data centers, in our VPCs, are not applied to what the users actually have on their computers. We don't control if the applications or the browsers are up to date. We don't control what users does underneath working with our application. And we build really rich APIs just to give them access to the data that we store in our secure environment. Now, the presentation today will focus on security headers. And TLDR, this is a way to actually extend the premise of secure space that we have and also instrument browsers to work with the same security policies and secure principles that we have internally in our data centers. And some of you may ask question, why should I care about this stuff? Because when I ship it to the user, I may not care about what happens to the code anymore. And if the user got hacked, it's his problem, not mine. And try to imagine this kind of article. So the customers of big bank lost their money. Huge number of customers. You'll probably notice the name of the bank that will be in such article and the fact that this was not secure because people lost their money. And no one will actually find this detail that, well, they were using a Internet Explorer 6 on Windows 98 or something really, really old and not up to date. This is something that will hit us as a company or the bank that is that's name on the main page. So our reputation is on verge here. So we actually should care. And I actually found it really interesting because this is article from yesterday from one of the Polish blogs. And there's a huge leak from Polish services. And if you go down the article, it's actually related to some malware that the guys were installing. But again, this is an exact thing that I showed you previously. It's an article about Polish services that tend to be not secure because there is a data leak, although it's not their fault. So I want to talk about security headers because I think this is important. And over the years, I worked as a DevSecOps engineer. Currently, I'm working in a company called Let's Go DevOps. So we provide DevOps and DevSecOps services to other companies. And during the process, we talk a lot with developers about architecture, security of their applications, try to move them towards cloud-native approach. And during those conversations, I actually found an inspiration for this particular talk. And when it comes to inspiration and those discussions, let me show you the quotes that I heard when I was talking with front-end developers. So first of all, one of the things that I heard is that I don't need those security headers because my backend is super secure. Now, this is really great that you use good practices when developing backend applications, but it's not the point. You will see from today's presentation that actually making sure that entire process is secure is really important because it's the weakest link that will break in your security chain. So also front-end and browser security is really important from the perspective of entire software. The second stuff that I really loved is like modern browsers are secure. So I don't need to think about security because we are using modern browsers. And that's the only comment I have for this sentence. So I started doing some demos and showing up that it's not the case in, well, many cases. So for today, I want to start with a little bit of why. And then I have 6 cases. Those cases will be structured in the way that I'm a young hacker that just started his career. I will show you exactly how the attack can be performed, and then we can talk about mitigation of each of those attacks. And we have some time in the end. We can have a Q&A session and discuss some of the topics. Just one disclaimer before I start. Those attacks that I will show you today, they will work in the real world on some of the applications. So just keep in mind that if you are doing any kind of penetration testing, you need to have a consent, because most of the countries actually take any form of penetration testing without consent as an illegal action. So your discretion is advised here, and let's get started. So when it comes to why, I already told you why I made the presentation, but let's think about the technology and what's underneath, so what we are actually using. And to get a big picture, I found few dates that are really important for us as software engineers. First of all, the Big Bang, because it all started there. The really sad part, the dinosaurs died, and now 1990, the start of the internet as we know it. So if you look on this picture, the internet is not that old. It's pretty new concept. So we have like 33 years of actually developing the stuff that is the internet. So if we look closer to those dates, 1994, this is when SSL 1.0 was introduced. 1996, it's HTTP 1.0. And that's interesting because before 1996, it was every company for themselves. There was no standard of sending stuff over the internet, so everyone could have its own protocol. HTTP 1996. And the last thing that I think is important in this picture is 2014, the death of the Internet Explorer 6. And I think it's the worst browser that we actually had. It was so buggy that it's the time where there was this comment that if you are using Internet Explorer 6, you are not browsing the internet is browsing you. And that's unfortunately the truth about the EA6. Now, 2014, if you look on the landscape, it's when security in browsers actually started to kick in. So it's a pretty long time from the invention of internet to the place where we started thinking about security. And also, I will show you that some of those concepts from EA6 are actually still alive, and we are unfortunately living with this technical debt. Now, to make it a little bit more fun or a little bit more scary, I have few cool examples of how the internet was designed and how it works. So first of all, no encryption standard until 1994. So just imagine it, in nowadays, we are talking about encrypt everything, but there was absolutely no encryption in the very beginning. And to make it worse, currently the network topology is usually A star, so you are talking to the router directly, so there is not much room to sniff on something. It's of course possible, but not that easy. Back in those days, everyone in the village was on the same wire, and you can listen to all the communications from anyone without any encryption. So that's really interesting stuff. Now, SSL 1.0 had a security flaws, and it could be hacked during minutes. And it's not about computing power, it's about hacking it with pen and paper. So basically, you got the first standard that if you were lucky, you could actually hack someone's banking session during his banking session with pen and paper and a calculator in your phone. So Yeah, that's a little bit scary. But you may say, okay, that's the internet. But I'm using a really secure Linux server. Linux was designed for security, right? And in here, the first Unix servers actually never ask you for a password. So when you are dialing in or telnetting into the first servers, they will just ask you who you are. And if you could type something along the lines of, I'm Groot, you were an admin on the server. So that's how it was built. That's how it was designed. The next thing is when the internet started and we had more and more application servers, the put method was public by default. So imagine browsing the internet with the change methodology that you have on Wikipedia. You go to Allegro, you find a cool product, you see, okay, it's really good stuff, but the price is not right. So let's just edit it, push it to the server, and it will be saved on disk. So that's the beginning of the internet. And finally, it's still really, really hard to change any security standards. We did one really good job, and this is when we were waiting for Internet Explorer 6 to die. But still, I find such pictures in some of the documentations, especially in the big companies. What is here is actually an instruction to go into your internet settings, find security tab, click on the custom level, and decrease everything down. Now, this will bring you back to 1990s when it comes to security. And one of the hacks that I will show you will actually work on those browsers, not the, let's say, not messed up ones. And the really interesting stuff about it is, of course, I did it because I needed to access the internal system, but I had this browser dedicated only for the internal stuff. But my colleagues were actually using this browser for every activity that they had, and this is really, really scary. To scare you a little bit more, there's also a shift when it comes to attack vectors. So previously, a lot of attacks were infrastructural level attacks or backend server attacks. And now we switch a little bit towards users. And a lot of those phishing campaigns, malware campaigns, they are targeting millions of people at once, hoping that 1% or 0.1% will just click on the link and we can continue with attack. So users became one of the weakest link or most vulnerable links in our chain. Are you at least a little bit scared about what I show you or not? I don't see anyone being scared. So let's start with the first example. And with those first example, I have this small remark, because I tuned it a little bit. This is something that I told you that we change one stuff in the internet, and it's really good. So the day one hack will work on old browsers, the browsers that were messed up with the configuration. But I wanted to add it to the presentation because I want to show you how it worked 10 years ago and what's the level we are starting the security debate from. So when it comes to the first day, I told you that I will be a new hacker, right? I just finished college, I don't have too much funds, I don't have too much knowledge, so what can we do? And to actually run this attack, I need some HTML and JavaScript. I can find it on Stack Overflow, or actually, if you are not that old, you can use ChatGPT to generate it. I'm just still a Stack Overflow guy, so Stack Overflow. I need a free hosting, and this will be interesting, because I need some hardcore social engineering skills. And I will show you those skills just in a second. Let's start from the beginning. So we need to create our evil site, where we'll be launching our attacks. Do you have any proposition for the name of the site that will be used for pure evil, for my evil company? If no, I went with fluffy.com. Fluffy.com will be my base of operations. The main idea is to show you pictures of cats and dogs and whatever. It will be fluffy.com, the source of all evil in this presentation. Now, the next thing are those social engineering skills. And what we need to do here is we need to find one of those portals where you can send a funny pictures and people will maybe click on those or upvote those. And I found a few of those. And if you look on the example on the app side, it's over 1,000K upvotes. I would assume it's at least 1 million entries to the site. And that's enough for me, for my social engineering, for the day one. So when you click on the link, I want to mention that I'm a DevOps, I'm not a front-end engineer, so my page looks like this. I know it's awful. Also, my code is awful. But what I wanted to mention here are 4 lines that I added as a script part. So first of all is the URL. I used facebook.com with some imaginary API just to show you that it's not my site, and this is where we are going to some other server. Of course, it's not about Facebook, it's about the destination. Next, I have a GET request I add with credentials, and finally, I send the request. And if you open it with the unsecure browser, under the picture you will see this. So it will say, hey, you are Jacek, and this is your session cookie. So coming into the fluffy.com, opening the site, actually interacted with third-party service, and it gathers some information about me from the server. So yeah, you might be wondering how it's possible. And let's go through the journey of what actually happened. And let's start with the legit use case. So first of all, if you go to a site like Facebook, you will send a GET request. You will get a response with a HTML. Browser will parse it. It will find all the resources that you need to download to show the page fully, so the server will just respond with all the resources that you have. Now, what will change if you are logged into the server? The short answer is that cookie will be issued for you, and from now on, every request that got the add cookie header will actually have cookie embedded, so then you can have a protected resources. So what happened in my example? So we went into fluffy.com. Fluffy.com returned an HTML, and then we had a JavaScript that was actually doing a GET request from some other website, and it was using with credentials. And with credentials, the browser thought, okay, you want to add a cookie, so let's add a good cookie. So the server responded as you were logged in. And yeah, that's how it worked in the example. And this is how it worked 10 years ago. So this is one of the biggest change that actually the default behavior for it changed. And it's a really, really great thing that it did. So the question to you, how can we fix this problem from a header's perspective? Of course. So cross-origin resource sharing, this is a header that we want to add to our configuration. And the change that I told you is that 10 years ago, if you didn't have this header, the assumption was anyone can read your content. Now the assumption is that if you don't have this header, only the same origin can read resources. So that's the big change. And this is why a lot of those corporate systems ask you to actually decrease the level of security because they don't know how to configure the cores correctly. The additional headers that I have here are equivalent of course for your JavaScript applets or Flash players. I'm not sure if anyone using those, so I just added those for reference. So let's go through the example with the course enabled. How will it work actually in the modern browser? So I go into fluffy.com, I got the same HTML. Now in HTML, there is my JavaScript GET request, but instead of GET, the browser will issue a header request. And the server will respond with headers. And in those headers, I will have information about course domains. And because the fluffy.com is not on the list, the request will be blocked. And it will never leave the browser. Now, I have a few questions to you. So first of all, RFC says it's OK. Access control allow origin with a star. Who thinks it will allow all domains to pull the resources from my site? Hands up. Who think it will not allow anyone to pull something from the site? Okay, 2 people. So is anybody listening to me except those 2 guys? Okay. So to give it into perspective, actually this is treated by browsers as a server misconfiguration. So it will assume that there is no header whatsoever, so only the same origin policy. If you want to open up your site to entire internet, you need to be a little bit more creative and return the exact domains that are requesting the content. This is treated as false configuration, although the RFC says it's OK to add it. The other question that I have, in here I have a link to some API, delete me, and it's a next button, or the image to delete me. Will this attack work even if you have a course set up? Who thinks it will work and it will delete an account? And 2 people, 3, 4. Who think it will not work? Okay, few other hands. So I will tell you, this will work. This is completely different type of attacks. It's called cross-site request forgery, where you are actually tricking user into doing a legitimate action, and this legitimate action goes to some harmful URL. And there are ways to actually protect you against those, but this is a topic for a completely different presentation. The next thing that I have as a question, it's similar concept to the previous one, so I'm using the image to access some endpoint. But if you look on the endpoint, the address is 192.168. So it's a private IP range, used usually in homes. Will this work? Who thinks it will? 1. Who thinks 2, 3, 4? Who thinks it won't work? Okay, so the correct answer is, unfortunately, this will work. Because what will happen over here is that you will download the page to your computer, and your computer will start issuing requests into the internal network. And this attack was used for a lot of home routers that had this GET API for opening router up for the entire internet. And the attackers were actually embedding thousands of pictures on the page with common passwords and common IPs. And the browser was trying to access all of those IPs. And if one of those succeeded, it was opening up your home router to the entire network or the entire internet. So then the hackers were actually coming to your DNS and changing it to them, so the man-in-the-middle attack came in. So this, unfortunately, will work. And this is really interesting stuff to remember, because if you think that this application is in my internal network, I need to have VPN, I can actually access your internal resources if I want to. So using you as a part of the chain, I can issue requests to the internal systems. OK, so that's it for day 1. Now let's go with the second day. So a little bit more sophisticated attack, because I already know how to code JavaScript, right? And the day 2 will look like this. I have a cool game in mind. So feed a cat. If you click on the mice, I will donate food for the shelter. We had some actions similar to it a while ago in Poland. So there's a mice. You take your mouse, click on the mice, and congratulations, food donated. And that's it. That's it for day 2. I just completed my hack. And what happened here? Any thoughts? I will show you the source code here. So I have this iframe with opacity set to 0. So basically, I have an iframe that's completely transparent. And with some presentation magic, I will show you how it actually looks. The truth is that, OK, the feed the cat would be underneath, so it not see it. So for presentation purposes, it's up. So in here, there's example with our LinkedIn profile or LinkedIn page. And here's the mice, the random place where it showed. Then somebody clicks on it, and voila, that's the hack. And there are 2 attacks that I actually added in this day. So first one is a mind game to actually drive you to our LinkedIn profile and ask you to follow. I will check on the stats if it works or not, because I'm not sure. The one that works is actually called a clickjack attack. So clickjack shows you a transparent page that you are interacting with, and underneath you see some kind of fun animation on game. And this was used actually when Google introduced drag and drop of documents between Google Drives. And how the attack worked is that the attackers created a game when on the left side of the screen you had these fruits coming down, and on the right side you had those baskets. And the truth was that on the left side was your drive, on the right side was the attacker's drive, and people were moving their files like crazy between those 2. So this is actually an attack that can be leveraged to steal data and to do harm. Now the question, do you know how to fix the issue? Block iframes, exactly. So iframes option, this is something that you can set up to either disable it completely, as usually we don't want our single page applications to be shown in an iframe. If you have a use case where you have partner that want to use your form or something like this, you can actually add URLs here, and it will be available for those particular cases and particular sites. So that's one of the options that you can go with. Now, the day number 3. So, stepping up the game. And in here, I have an additional question for you. This is part of my code. So it says it's a cat PNG, photo of dog, and to make it a little bit more complicated, that's how it shows in browser. Now, the question for you is, whether it's a cat, hands up. Who thinks it's a dog? Who thinks it's something completely different? Okay, a few hands. So the answer to it is it's JavaScript. And again, this was one of the attacks that went live. So you can embed JavaScript into other resources. And in this particular example, the attackers were able to bypass the threat detection system, because the threat detection system was parsing the stuff like the image. But in fact, the JavaScript was there. And the browsers are interesting, because whenever you pull something, it's a block of data. So they don't know what they are pulling. And there are those MIME types that you should set up for every resource that you have to instrument the browser and tell it, OK, this is image, this is JavaScript, and so on. But because people are not using those, the browsers have this AI tool built in that actually looks on the content and tries to determine whether it's JavaScript or not. And despite what you said in MIME type, browsers will actually also launch this AI, and the AI is usually a higher priority than what you said in your configuration. So that's actually a problem. And of course, it will not work if you just put it into image tag, because it will be displayed as image. But if you are able to upload it to server and then somehow reference it as part of the script, you actually bypass some part of securing mechanisms on there. So yeah, that's a great question. So how can we make browsers not try to outsmart us, so disable this AI? Any idea? If not, that's the header. So X content type option, you can disable the smartness of the browser and just say that all the MIME times that I'm providing are correct ones, and therefore you will not have this magic of showing JavaScript or putting JavaScript inside the images. Okay, the day 4, stepping up the game a while more. So day 4 is a little bit more tricky. So it's about injection. And again, when we talk about injection, usually your head goes into SQL injection or something like this. And today I want to talk about something completely different. So I want to talk about script injection, because we can inject absolutely everything to application. Even if you have someone reading the bash prompt, you can actually try to influence his bash on the logs if you want to. So script injection, it's a lot more tricky when it comes to single-page applications, because when you think about those, first of all, server-side and user-side. So server-side are the injections where you actually interact with a server, you push data there, and you need to bypass all the measurements on the server just to return the data to all users. And that's really cool part, because if it's persistent, all the users of the application will be affected. The user side is something where you try to inject a script into the user browser. And that's the type of attack that we'll be talking about. So for single page applications, there is this way of actually creating a link that will get back to exactly the point where you were as a user. So you are starting to accumulate data after this hashtag, right? You put more and more steps, or you try to find context within this data. In some cases, if you don't do a proper sanitization, you can actually put some kind of script in there. And then, okay, nobody will click on 32-byte URL, right? But you can do something like this, or you can do a redirect, and user will not know that he's actually redirected to site that has a script that is rendered only in the browser. Now, those attacks are really hard to find, because they are not interacting with your backend server at all. So all the cool stuff that we talk about or we thought about in backend will not apply here. I can actually download your page, turn off the internet connection, and try to hack it, and you will have absolutely no knowledge about that I found the hack there. And that's a little bit scary, because you can inject script in many places. So what can we do to prevent it? It's a content security policy, CSP. Now, CSP, if you want to just one header take out from this presentation, take this one. I think it's the most powerful stuff that you can do with headers. CSP tells the browser exactly which source can be used for downloading JavaScript, downloading images, and all other resources. And it's not only about the domain. You can specify full URLs. You can also add a hash of the file. So tell the browser that only this script with this particular checksum can be executed within my context. And really cool feature about the CSP is that you also set a field where the browser should send you a report about any malicious behavior. So if somebody is trying to hack your front-end application, the SPA, the browser will actually send you all the reports with all the data that he's trying to inject and all the stuff that wasn't added to CSP. This can be used in both ways. So first of all, it's a early response or something that will help you out diagnose the problem and notice that somebody is actually tinkering with your app. The second thing is that when you are setting up CSP, you will get the reports of all the stuff that you missed. And CSP have two options to work in. First one is report, and the second one is block. So if you don't have CSP, you want to enable it in reporting mode, go through all the reports, add all the sites or all the libraries that you are using, make sure that you don't get any more reports, and then switch CSP to block method, and your app will be a lot more secure. The only downside is that it will not allow for inline JavaScript. So everything that you have on page needs to actually be moved to a separate files, and those files need to be referenced in the content security policy. Okay, day 5. So 2 more days to go. Let's think about some more passive income, because everything that we did so far required a lot of goofing around the internet. And for preparation, I have this idea of, well, sharing something, most likely for free. So let's think about the library, some kind of file, maybe image or something like this. And the goal here is to actually drive people to download it from your site. It can be totally legitimate. We don't need to mess it up. Maybe we just found a way that, okay, you are using this JavaScript library that has a lot of components, and let's build it in the different ways so you can pinpoint exactly parts that you want, and this will be much faster and so on. I don't care. The only thing is that I care that people actually add it to their site. And okay, where's the gain in this part? So when you come to your server that's hosting the files, and add this part to your logs, we will be actually getting a referrer information. So whenever any user comes to any page that downloads my content, I will see in logs exactly the entire URL with all the params that the user is having. So when browsing such logs, we actually found that a lot of tokens, password reset tokens, magic links, so click here to log in automatically, this all goes into the referrer header and is sent to a third-party service. Also, I can look onto it and check out what's your application internal structure, so a lot of those URLs just pop up. So I'll have a lot more knowledge about the admin endpoints. You never showed them to me, but if you are using file from my server, I will get the referrer header, and this referrer header will actually show me where the admin panel is. Okay, so what can we do with this stuff? And the obvious answer is to drop or disable sending the referrer. I'm not sure why the referrer is still with us. I do have a feeling that is, something that was invented a long time back, and we decided that, okay, it will stick because maybe someone is using it. Personally, I don't see any gain in using the referrer header. basically we never use it, or you should not build the security on the referral header. So it's maybe for debugging. From my perspective, it's okay to disable it in 99% of cases. Okay, and one more day to go, and we can go with Q&A session. So for day 6, I'm already, proficient hacker. I have some money that I spared, so we can do something more challenging. And for something more challenging, let's start with the question. It's a banking site. It's complete coincidence that you might know the logos or something like this. It doesn't matter. What's wrong with this part of the picture? Exactly. We are missing the S. It's HTTP, not HTTPS. So actually in here, it could be a man-in-the-middle attack. So let's think about this idea. So with man-in-the-middle attack, what we need to actually make it happen is, first of all, we need one man, because it's man in the middle. Then it's at least one laptop, and we need some free Wi-Fi, Starbucks, conference. It doesn't matter. The truth that you need to know about Wi-Fi is that your device will pick the access point that has a biggest antenna or has a best quality signal. So if I'm closer to you than access point, the official access point, you will probably connect to my access point. And even if you are already connected to the conference one, I can send a roaming request, and you will be actually looking for the better suited device. So I will force your device to connect to my laptop and be your man in the middle. So that's a simple approach. If we have enough funds, we can go with something a lot more advanced. And a lot more advanced, I mean Wi-Fi Pineapple. This is a box that is already designed with multiple antennas, with pretty strong signal, with tooling that will automatically disconnect you for current network, switch you to mine, use the original network of the building to actually send the traffic in. And this is a built-in device for man-in-the-middle attacks. And yes, it's expensive. It's cost a little bit over $100, so 120. You need to wait 3 weeks to get one of those. And if you so far thought that you never met a person who owns the device, I actually brought one with me. But I told you that, penetration testings that are without consent are illegal, and we haven't added it to a terms and condition of the event. I was not allowed to enable it. So I have it. Maybe on the next Devoxx we will have a additional checkbox to tick to actually play around with the device itself. But from now on, you can actually say that you met a person that carries around Wi-Fi Pineapple and could do a man-in-the-middle attack for all of you in this room. That's without any problem. Okay, so how can we protect against this stuff? And in here it's a HSTS, so HTTP Strict Transport Security. The header will basically show, tell the browser that if you are connecting to my site, I will be always using SSL. So don't even bother to send me non-encrypted requests. Everything will be pushed in SSL. And that's really good because keeping the SSL up and running is really easy. You can go with Cloudflare and just click, I want to have a certificate issued for my domain. And that's good enough. And everything will be encrypted. The next header here is a public key pinning. This is a real pain in the butt. So if your application doesn't need it, I don't recommend tinkering with it. The way the public key pinning works is that not only you tell the browser that this is that the site will use the SSL, it will also use this particular certificate for at least a year or half a year, and come to me back in half a year to get a new certificate pinning. And that's a really powerful stuff, but it's really hard to maintain the list of those. So huge pain in the butt, but it protects you from the situation where someone will, for example, steal your domain. So if he does, he can actually issue the certificate, and the HSTS will not help you in this case because the certificate for domain is valid. The public key pinning will prevent it. So if you are a banking site, if you do a lot of stuff with money and so on, maybe public key pinning is something that you should do. but definitely HSTS, the first one, is something that's really easy to enable and really easy to maintain. And yeah, that's all from my side with the presentation. As a disclaimer, if you saw any logos, names, and so on, it was completely coincidental and unintentional. And actually, no one was harmed during creation of this presentation. So no hacks were actually pushed anywhere to the world. So thank you very much. And if you have any questions, just shout them out now.